Let's continue with example 4, which is this is also the example of probability with independent event. So let's try to read this question first. There are 60 students in a certain college. 27 of them are taking mathematics, 20 are taking biology, and 22 are taking neither mathematics nor biology. Find the probability that a random selected student takes both mathematics and biology, mathematics only. B. A student is selected at random. Determine whether the event taking mathematics is statistically independent of the event taking biology. Alright, so in order to illustrate all of this information, whereby we have a 60 students and also we have a 20 students who are taking a mathematics subject, and also 20 students who are taking biology, and 22 students are taking neither mathematics nor biology, which means they are not taking both of the subject. So in this case, I already illustrated in the Venn diagram. So we're supposed to have these types of Venn diagram, okay, and from this we know that our total sample space of this Venn diagram is actually equals to 60. Okay, we have the informations of students who are taking mathematics, and we also have the informations of students who are taking biology. So in this case, since we do not know the value of the intersection between both subjects, so we're going to put it as an x variable. So for this value, for sure it is equals to 27 minus x, and this is actually 20 minus x. Then in order to find the value of x, we are going to use the value of the sample space, which is 60, which is equals to the 27 minus x plus x and plus with 20 minus x. So let's try to find the x by adding all of this value. So we have 27 minus x plus with x and plus with 20 minus x equals to 60. Then from here we will have minus 7 plus 20, okay, and then we have a minus x equals to 60, or we still have one more, which is 22. Sorry, so this is actually plus 22 equals to 60. Okay, then we're supposed to have plus 22 minus x equals to 60. Then after adding of this value, 27 plus 20, we got 47, and then plus 22, we got 69. Okay, and then minus with x equals to 60. Therefore we have x equals to 9. Okay, so now we already have the value of x, which is equals to 9. So then we can start looking for the value of this one Roman and the second Roman. So find the probability that randomly selected students takes both mathematics and biology. So we are looking for the value of intersection. So for first Roman, we are looking for probability of m intersections by b, whereby we know that this is actually the value of x, which is equals to 9 divided by 60 total sample space. So therefore, after simplifying, we're supposed to get 3/20. Okay, then the second Roman, okay, we are looking for the probability of that randomly selected of mathematics only. So we are looking for this value, actually 27 minus x. So we know that now we're just looking for the value of probability of m intersect with b complement. Okay, so if I just illustrate in the Venn diagram, this is actually the region that we're looking for. Okay, so this is actually equivalence to m intersections by b complement. So therefore, we know that this is actually 27 minus x. then will be equivalent to 27 minus 9, which is equals to 18. Dividing with a sample space, which is 60. Therefore, after simplify, you may have 3/10. Okay, so now let's proceed with B. Okay, so a student is selected at random. Determine whether the event taking mathematics is statistically independent of the event taking biology. So in order to prove that these both events are independent, so we have to make sure that the probability of M multiplied with the probability of B must be equal to the intersections value, as we discussed earlier in our previous video. So this one must be equal, then we can say that these both events are independent. Okay, so now let's try to do this. So according to this Venn diagram, so we should have the probability. We know that, okay, for B, the probability of M intersections of B, which is equals to 3/20, sorry. Okay, and from here also the probability of M, we're supposed to have 27/60, which is, after simplify, we're supposed to have 9/20. And now we're looking for probability of B, which is equals to 20. All right, 20/60. After simplify, you may have 1/3. Okay, then this one we have to multiply probability of M and probability of B. So this one will be equal to 9/20 times with 1/3. So therefore you're supposed to have 3/20. So by looking on this, the value of probability of M multiplied with probability of B is equals to the probability of M intersect with B. So therefore we can say that, okay, we can say that the two events, okay, are independent each other. For example 5, the probability that Roy is late for college on any day is 0.15 and is independent of whether he was late on the previous day. Find the probability that he, A, is late on Monday and Tuesday, B, arrives on time on one of these days. So according to these informations, we know that the probability that Roy is late is 0.15. This is actually the two possible outcomes that we will have from these experiments or from these events, whether he is getting late or he is on time. So in order to illustrate these informations, we are going to do in the tree diagrams. Okay, so let me just draw the tree diagram first. Okay, so this is actually late and on time. Okay, so we know that the probability that he is getting late is 0.15 and the probability of his on time is 1 minus 0.15, which is we're going to have 0.85. This is actually on the first day, which is on Sunday. Okay, and then we continue with the next day. Okay, with the next day, let's say that the next day also will be the same results, which is whether he is late or he is on time. Okay, so now here is 0.15 and here is 0.85. The same thing goes to here, so we will have late, on time, and here the value is 0.15 and 0.85. So this is actually on sorry, this is supposed to be Monday. Okay, so this is actually supposed to be Monday. and Tuesday. Okay, so now, so according to these three diagrams, we know that this is actually independent events between these 2 days, okay, as it is mentioned in the questions. Okay, so now let's start answering for A, which is we are going to find the probability that he is late on Monday and Tuesday. So he is going to be late for 2 days, which is Monday and Tuesday. So now we are going to find the probability, which is 2 days he is getting late, so which means that this value. So in order to do this, so for A, probability that he is getting late on Monday and Tuesday. Okay, so this will be equivalence to, so now since these three diagrams between these 2 days, so it is independent to each other, so therefore we should multiply of these two values. So this is actually will be equivalence to 0.15 multiply with 0.15, which is equivalence to 0.0225. okay, and then for B, so the probability that he arrives on time on one of these days. Okay, so now we're looking for probability of he arrives on time on one of these days. Okay, and then here from this three diagram, so we are going to pick up which at least one of the days he is arrive on time. So I'm going to highlight, so this one, okay, so this one, which is this one, okay, and also this one, okay, and this will be equivalence to 0.15 multiply with 0.85 plus with 0.15 multiply with 0.85. So this will be equivalence to 0.1275 for both. Then this will be equivalence to 0.2550.